Welcome to Pharmaceutical Calculations, a Conceptual Approach, Lesson 8. In today's lecture, we're going to use some of the concepts we have discussed in Lesson 7 related to units of concentration and solve some of the compounding exercises. Let's start with the 4.50. This is, it contains calcipotriene. It's a lotion. And it is used for psoriatic patients. The first question is asking you to calculate the amount of calcipotriene needed to fill the prescription. Then C is asking you to calculate the grams of glycerin contained in this prescription. And D is asking you to calculate the zinc oxide in this prescription, the concentration of zinc oxide in the lotion. So let's start with A. In order to calculate the calcipotriene required to fill the prescription, we're going to use the concentration of it. So this is 50 nanograms per microliter. And because I have 60 ml, I have to change the units. So this is equal to 50. I just multiply it by 1,000, numerator and denominator. Becomes micrograms per ml, and then multiply by the volume of lotion, and I end up with 3,000 micrograms or 3 milligrams of calcipotriene. The next question is glycerin contained in this prescription, and we're given the specific gravity of glycerin, and we know that it is equal to density when it is expressed in grams per ml. Now we have the concentration by volume for glycerin, and we need the grams, so we're going to have to use the specific gravity. Now be very, very cautious here. The specific gravity that is given here is for glycerin. It is for the solute, not for the solution. Okay, so be very, very cautious. 10% by volume is basically 10 ml of glycerin over 100 ml of lotion. And now the specific gravity, since it is for the solute, I have to apply it to the numerator where the glycerin is, not the denominator. Be very, very cautious here. So times 1.25 grams per ml. And because I have 60 ml of total lotion, and I need to calculate the grams of glycerin in the lotion, I have to multiply by 60. So this is lotion here. So ml and ml cancel out, ml and ml cancel out. 0 and 0 and 0 and 0, so I have 6 times 1.25, and therefore I have 7.5 grams of glycerin. That's my answer for C. The last one is to calculate the percent weight per volume of zinc oxide in lotion. So here zinc oxide we have this AA here, so it must be 4 grams also of zinc oxide, and this 4 grams is in 60 ml. So I have 4 grams in 60 ml. In 100 ml, how much? And X is equal, we just have to cross multiply here. So 40 over 6, that's 6.67 grams in 100 ml, or 6.67%. Weight per volume. Okay, so this is what we have. Let's move to the next one now. Calculate the quantity of beta-methazone present in 8 ounces of 2.45% weight per weight beta-methazone cream. So obviously here, first we need to apply the conversion, convert the 8 ounces into grams, and then multiply the grams of cream by the concentration of beta-methazone in the cream. 1 ounce is 28.3 35 grams overalls there. So I have 226.8 grams of cream. And then I can just multiply that cream times the 2.45% weight per weight, so that's grams of beta, over 100 grams of cream. So the cream and cream cancels out, the grams, and my answer here is 5.56 grams of drug, beta methaz. Okay, so this is what we have here. So again, you need to calculate the total quantity of cream and then multiply the amount of cream, the grams of cream, with the concentration of betamethasone in the cream, and that would be your answer. Example 4.4, we need to convert HCl 37%, so this is a strong acid and is given as weight per weight. And we need to convert weight per weight into weight per volume, and now here we're given the specific gravity of the solution. So be very careful here. It's not for the solute, it's not for the HCl, it's for the solution. So you have to apply it to the denominator. So let's start by writing the concentration. 37% weight per weight, it's 37 grams of HCl over 100 grams of solution. And since the specific gravity is given for the solution, I have to apply it to the denominator. And in order to convert the weight into volume, I have to divide by the grams per ml. So that's 1.23 grams per ml. Now because I'm going to keep the denominator equal to 100, as you can see, percent weight per volume is also in 100 ml. I'm going to just multiply the numerator now. So it is the density of the solution, but in order to keep the denominator equal to 100, I multiply the numerator. So now grams and grams cancel out, and what I have there is equal to 45.51 grams of HCl per 100 ml of solution, or 45.51% weight per volume. So 37% of HCl weight per weight is equal to 45.51% weight per volume. And this is the answer in type down for you guys, so when you go home you can read it at your own time. The important aspect again here is to realize that this is the density of the solution. It has to be applied to the denominator. In order to keep the denominator 100, I multiply, instead of dividing the denominator, I multiply the numerator, and I get my answer as 45.51% weight per volume. Now if you wanted to divide the numerator, you're going to end up with 37 grams of HCl in 81.3 ml of solution, and in order to get the concentration as percentage weight per volume, you're going to have to normalize your denominator into 100 ml. So then cross multiply and you get your answer. Either way is fine, whatever you are more comfortable with. Now in example 4.6, we have to do the opposite. So we're given antipyrine as 2.5% weight per volume, and we need to convert it into weight per weight. The specific gravity of the solution, again, antipyrine solution, not antipyrine solute, is 1.25, so that's grams per ml. And I've written my answer here, I typed it because we know what to do now. So the 2.5% weight per volume is 2.5 of drag over 100 ml of solution. And if I'm gonna convert this into weight per weight, I'm going to have to multiply the density of the solution to the denominator. I have to apply it to the denominator. And because I want to keep my denominator as 100, I'm going to divide the numerator here. And I end up with 2 grams per 100 grams or 2% weight per weight. So again, the critical step again is to realize that the density of the specific gravity is given for the solution, and whatever arithmetic you need to do, you have to do it to the denominator. Now the next one, exercise 436, the percent weight per volume of a 5% drag solution is 4. Calculate the specific gravity. So here, what we are given is that 4% weight per volume is equal to 5% weight per weight. There may be multiple ways. I'm sure there are multiple ways to solve this. I would, whichever way you are going to follow to solve this problem, you're gonna go by the units. And since I have no idea how to solve it, I'm just gonna write the equation for the specific gravity or density. So the density is the mass over volume, and it's usually given grams per ml, correct? So I just have to have grams as a numerator and mLs as denominator. Now the 5% weight per weight, so here it is, that's basically unitless, right? Because it's grams over 100 grams. So essentially you have no units for that. So it tells me that in order to get the density, excuse me, I'm gonna have to have the percent weight per volume as the numerator because it's already grams per ml. So I'm just gonna write it here, 4 grams per 100 ml. And here I have 5 grams per 100 grams. So grams cancel, and I end up with grams per ml. So 100 and 100 cancel out, and I have 4 over 5 grams per ml, which is 0.8 grams per ml. So my specific gravity density is 0.8 grams per ml. Okay, example 4.9 now is asking you to calculate the nanograms of arsenic in a glass of water if the concentration of arsenic in drinking water is no more than 10 parts per billion. And usually all of these exercises, parts per million or parts per billion, we solve them by just writing the definition of the concentration down. So this is 10 ppb means 10 grams of arsenic in 1 billion, 10 to the 9 grams of water. And now because I want to calculate the nanograms, I'm going to have to convert my numerator into nanograms. So 10 grams times 10 to the 9 nanograms per gram of arsenic over 10 to the 9 ml of solution. So the density here is 1 because it's so dilute. A glass of water is 250 ml. So in 250 ml, how much of arsenic do I have? So cross multiply and you get your answer as 2.5 micrograms of arsenic. Exercise 4.11 is asking you to calculate the equivalence present in 45 ml of 1.2 molar sulfuric acid. Now this is a strong electrolyte, and remember in our definition of equivalence or normality, I specifically stressed, emphasized that you need to know the reaction. So this is a strong electrolyte, it's a strong acid, and it dissociates fully. So we don't need a double arrow, just single arrow here. It dissociates fully into two protons and the sulfate route there, which is bivalent. So the number of electrons or protons that participate in this reaction is 2, because it's 2 times 1 or 1 times 2, which again is 2, right? So 1 mole dissociates into 2 moles of protons here, or 1 mole of the bivalent route. So either way, the number of electrons that participate in the reaction, taking into account the valence and the stoichiometric coefficient, is 2. Very, very important. So the definition we gave in lesson 7 about the normality, that is the number of protons or electrons participating in the reaction, don't take it lightly, okay? We are applying it here now, as you see. Now, we know that normality is equal to n times m. So n is 2, and we have 1.2 moles per liter. So what do we have here? So this is equivalents per mole, equivalents per mole, and this is moles per liter. So moles and moles cancel out, and you have 2.4, right? Equivalents. Per liter. So normal. Okay, good. So now we need to multiply by the volume. So the equivalence is equal to 2.4 equivalents per liter times 0.045 liters. So now 45 times 290 plus 18, so that's 0.18 equivalents of sulfuric acid, or of hydrogen plus, or the sulfate route over there. Okay, nice. So again, the definition we've given for the units of concentrations are supposed to be applied in order to solve these problems. So you're not going to memorize these definitions to understand the definitions. I have set a number of exercises for you to practice. Practice is necessary, and it is the only way to be proficient in solving problems, compounding problems related to the units of concentration. And at this point, I would like to thank you for your attention. Until next time.